To solve a rational equation, you need to multiply every term by the least common denominator. That's going to clear out your fractions and give you a really nice equation to work with. So let's take a look at this first example. So you want to look at your denominators. You have a 3, a 10, and a 5. So you have to pick a number that 3, 10, and 5 will all go into, preferably the smallest number. So I think to myself, what does 10 and 3 and 5 go into? And I see that that's a 30. So that I'm going to multiply every single term by a 30. Now you realize that's like 30 over 1, which means that that 30 is in the numerator, so it allows me to cancel that 3 into that 30 10 times. And 10 goes into 30 3 times. And 5 goes into 30 6 times. So I take what I have left over, that 10 times that 2x, to give me 20x. Then here I take that 3 times that x minus 5 to get 3x minus 15. And lastly, I'll take 6 and distribute that through to give me 12x plus 18. Now we have a nice equation to solve. Collect your like terms, so 23 minus 15 is equal to 12x plus 18. Subtract your 12x, subtract your 12x. That gives me 11x minus 15 is equal to 18. Add your 15 over so that I have 11x equals 33. Then divide by 11 to get x is equal to 3. Okay, let's take a look at the second example. On the second example, again, we want to look at our denominators, a 4, a group of x plus 1, and a 6. And we need to think to ourselves, what is a denominator that each of those will go into? I know that 4 and 6, I could pick 12, and that'll take care of those two. But we have to have something that x plus 1 goes into, which means we have to have an x plus 1. You have to pick a denominator that can accommodate each of those individual denominators. So I'll multiply every person by a 12 and an x plus 1, a 12 and an x plus 1, a 12 and an x plus 1. So then let's say 4 goes into 12 3 times. X plus 1 and x plus 1 are going to cancel. 6 goes into 12 2 times. All right, let's see what we're left with. Here we have 3 times 3 and an x plus 1. So 3 times 3 is 9, and your x plus 1. Plus, here you have 12 times 2, which is 24. And here I have 5 times 2 times an x plus 1. So that's 10 and x plus 1. So then distribute. That gives me 9x plus 9. Bring down your 24 is equal to 10x plus 10. To solve this equation, collect your like terms. So 9x plus 33 is equal to 10x plus 10. Get your x's together. So I'm going to subtract 9x from both sides. You could have brought the 10x over. That's your choice. Then I would have 33 is equal to x plus 10. Then subtract your 10 over. And 23 is equal to x. Okay, let's take a look at example 3. So we are looking at our denominators. We have this, this, and this. And we need to pick a denominator that each one of those will go into. However, before I do that, I really need to see what those denominators are. So we need to factor. That's really an x and an x minus 5 when I take out the greatest common factor. That's, of course, just an x. Here, you can take out the greatest common factor of a 2 and be left with x minus 5. Now, I'm going to lightly kind of go through those so that I don't look at them in that way. Now, we got to pick a denominator that can handle or accommodate each of those individual things. I've got to be able to accommodate a 2. I've got to be able to accommodate just a single x, and I've got to be able to accommodate x minus 5. So I have to pick a denominator that x, a 2, and the group x minus 5. So I'm going to multiply a 2x and an x minus 5. A 2, an x, and an x minus 5. A 2, an x, and an x minus 5. All right, let's cancel everything that we can. Those x's cancel. The x minus 5 group cancels. Here, just your x is going to cancel. Here, your 2 cancels and your x minus 5 cancels. Okay, it's looking messy, but we got to be careful and see what's left. So here I have a 2 and a 7, which is 14. Plus, here I have 2 times an x minus 5. So that's 4 times x minus 5 equals, and here I just have 3x. Then we're going to solve. So distribute your 4 through the parentheses and get 4x minus 20 equals 3x. Collect your like terms. This is 14 minus 20. So I have negative 6 plus 4x is equal to 3x. We need to get those x terms together. So I'm going to subtract the 4x over here. That says that negative 6 is equal to negative x, and of course I'll divide by negative 1, and x equals positive 6. All right, let's look at example 4. So at example 4, I want to look at my denominators. I have an x minus 7, I have an x minus 6, and then I have this trinomial of x squared minus 13x plus 42. So I need to see what I actually have so that I know what denominator to pick. So we need to factor that trinomial, what multiplies to get x squared, what multiplies to get 42, but adds to get negative 13. So a negative 6 and a negative 7 will add to get negative 13, but negative 6 and negative 7 multiply to get 42. So the common denominator that I'm going to pick is an x minus 7 and an x minus 6. Each of those individual denominators will go into that. So multiply every single person by an x minus 7 and an x minus 6. An x minus 7 and an x minus 6. An x minus 7 and an x minus 6. All right, let's cancel what we can. The x minus 7's cancel. The x minus 6's cancel. And they both cancel on that one. So see what you're left with. I have a 9 that is going to distribute through each of those. So that'll be 9 times x, which is 9x. 9 times negative 6 is negative 54. Here, that negative tells me to be careful. That's the red warning flag. You have to take that negative through that parentheses. So in fact, that becomes negative 7 times x, which is negative 7x. Negative 7 times negative 7 is positive 49, is equal to, and then all I have left right here is just a 13. Then I will solve my equation. Get your like terms together. 9x take away 7x is 2x. Negative 54 and positive 49 is going to give me minus 5 is equal to 13. Add your 5 to both sides. So 2x is equal to 18. Divide by 2 and x is equal to 9. Okay, let's take a look at example 3. Look at your denominators. You've got that trinomial, and then you've got those two just single binomials. You've got x plus 2 and x plus 3. All right, we're going to find a denominator, but before we do, we need to see what this actually is. That's another trinomial that can factor. So it's x times x, and then multiplying to get 6, but adding to get 5 is 3 and 2, with them both being plus signs. So I'll kind of swoosh through that. And then I have an x plus 2 and an x plus 3. So remember, you've got to pick a denominator that can accommodate or handle each of those individual denominators. So that means I'm going to have to be able to accommodate or handle x plus 3's and x plus 2's. So I'm going to multiply every single person by an x plus 3 and an x plus 2. An x plus 3 and an x plus 2. An x plus 3 and an x plus 2. Cancel everything that you can. The x plus 3's and the x plus 2's cancel. Your x plus 2's cancel, and here your x plus 3's cancel. All right, let's see what we have left. We just have a 3, so bring that down. Plus, right here, we have x minus 1 and x plus 3. So you have x minus 1 and x plus 3. Here, I have 7 and x plus 2. So 7 and x plus 2. So bring down your 3, plus right here we need to distribute or FOIL. I usually say distribute, but FOIL is the same thing. That x is going to go to every one of those, and then the negative 1 says, okay, now I'm going to distribute to every single one of those. And so I have x times x, which is x squared, and then x times 3 is 3x, and then negative 1 times x and negative 1 times 3. Distribute your 7 through, and you get 7x plus 14. All right, collect your like terms. I have x squared plus 2x, and then those 3's cancel, equals 7x plus 14. Now, remember, when you have a quadratic, which is what that is, it means you have to the second power, you need to set it equal to 0 and try to factor it. So I'm going to subtract 7x, come over here and find his friend. I'm going to subtract 14, so come over here and subtract 14. That gives me 0 over there. Over here I have x squared. 2 minus 7 is negative 5x minus 14. This is another trinomial that needs to be factored. So I will say my parentheses. So I'll have x and x. What multiplies to get 14 but adds to get 5 is 7 and 2. But look at your middleman right here. It's a negative 5. So we need those negatives to win. We need a negative 7 and a positive 2. At this point, remember that you come over here and you set each factor equal to 0. And so that's going to give me add 7, and x is equal to 7. Subtract 2, and x is equal to negative 2. All right, we want to check our answers. In these types of problems, you might get a solution that's actually not a solution. In mathematics, we cannot have a 0 in the denominator. So I'm going to look at these two answers, and I need to just make sure that they don't give me a 0 in the denominator of my equations. Well, if you look at this right here, x is equal to negative 2. If I were to put a negative 2 right there, that means I would have negative 2 plus 2, and that would be a 0, making my equation undefined. So therefore, I need to throw that answer out, but I can keep that one right there. All right, let's take a look at example 6. So look at your denominators. You have x plus 5, x squared plus 8x plus 15, and x plus 3. So we have to pick a denominator that can accommodate or handle each of those denominators. Well, let's see what we got. We know we got an x plus 5 there. Here, when this trinomial factors, we have x plus 5 and x plus 3, because 5 times 3 multiplies to get 15, but 5 plus 3 adds to get 8. So swoosh through that, and we have an x plus 3. So we need x plus 5 and x plus 3. That's the denominator that will accommodate or handle all of those other denominators. So I'm going to multiply by an x plus 5 and an x plus 3. I'm going to multiply by an x plus 5 and an x plus 3. X plus 5 and x plus 3. Okay, my x plus 5s are going to cancel. They both cancel. And my x plus 3s cancel. All right, let's see what we got left here. We have a 2x and an x plus 3. So a 2x and an x plus 3. Here we have this left, but we have this left with a warning sign, a warning flag saying be careful for your signs. That's what we have. So that's going to give me, and that's negative's going to go through, so that's going to be negative to the x squared. Negative to the negative turns into a positive x, and negative to the negative turns into a positive 10. Over here you have a 3 and an x plus 5. So 3 and x plus 5. All right, let's see and distribute. So that's 2x squared plus 6x, and we're just going to bring all of this down. We're going to distribute this to get 3x plus 15. Collect your like terms. 2x squared, take away 1x squared, is x squared. You got 6x plus 1x is 7x plus 10. Over here, your like terms are already together. Remember what we said a second ago. When you have a quadratic, you have to set it equal to 0 and try to factor. So subtract 3x, come over here and find his friends. Subtract 15, come over here and find his friends. So I have 0 here. That gives me x squared plus 4x minus 5. And I want to factor that. So it is a trinomial. So I think what multiplies to get x squared, which is x and x, what multiplies to get 5, which is 5 and 1, but it adds to get 4. Now you want positive 4. You want to positive. So you need for the positives to win that thing. So 5 take away 1 is 4. Set each one equal to 0. Subtract your 5. Add your 1. But again, we need to check these answers. We need to make sure that when we plug those back in, it doesn't give us a 0 in the denominator, because that would make us undefined. And if you notice, if I were to put that -5 right there where X is, because he can go live in his house, that's going to give me -5 plus 5, which is 0. And I can't have a 0. It makes your equation undefined. Zeros in the denominator are bad. You can't have them. So that answer doesn't check, but that one is going to be good. Okay, let's take a look at example 7. In example 7, just like all the other examples, we're going to look at our denominators, x plus 1, x squared minus 1, and what I would suggest, write that over 1 so that you can kind of be consistent and see them all as denominators. All right, so let's see what we got here. That is a difference of 2 squares, x plus 1, x minus 1. That just is x plus 1. So our denominator that we need that can accommodate or handle all of the other individual denominators, we need x plus 1 groups, and we need x minus 1 groups. So let's multiply every single person by an x plus 1 and an x minus 1, an x plus 1 and an x minus 1, an x plus 1 and an x minus 1. Okay, let's see what cancels. X plus 1's cancel. They both get to cancel, and then nothing cancels. All right, let's see what we're left with. We are left with an x minus 1 and a 4x plus 1. So an x minus 1 and a 4x plus 1. Here we're left with a 12. Here we're left with all of these things. A 3, an x plus 1, and an x minus 1. All right, we need to distribute. X goes through to everybody, and then -1 goes through to everybody. That's 4x squared plus x minus 4x minus 1. Just bring your 12 down. Here, we need to, again, distribute. I'm going to do that first and then take a 3 through. So that's x times x is x squared, but times 3 is 3x squared. X times -1 is -x, but times that 3 is -3x. 1 times x is x, but times that 3 is 3x. -1 times 1 is -1, but times that 3 is going to be -3. All right, let's clean up each side. So that would give me 4x squared minus 3x minus 1. Over here, I have 3x squared. Your x's are going to cancel, and you have 12 minus 3, which is 9. All right, once again, we have a quadratic, so we need to set it equal to 0 and try to factor. So I'm going to subtract 3x squared, come over here and find his friends. I'm going to subtract 9, come over here and find his friends, so that I have 0 over there. So I have x squared minus 3x minus 10 is equal to 0. Use your our factor here. So I'm going to say x and x. We got to think about what multiplies to get 10, but somehow adds to get 3, and that's 5 times 2. You want the negatives to win this thing, so -5 and +2. So set each one equal to 0. And then I will get x equals +5 and x equals -2. We probably want to do just a spot check just to make sure. If you look at your denominators here, the only thing that would mess you up is a -1 or a +1. So both of those answers are going to check. Okay, last one. All right, let's write this over 1 so that we kind of just stay consistent. So my common denominator, look at all the things you've got. You've got an x that's just by itself. You have an x plus 3 that's in a group. So my common denominator is an x by itself and an x plus 3 as a group. So x plus 3 to you, x plus 3 to you, x and x plus 3 to you. Cancel, nothing cancels, and your x plus 3's cancel. Let's see what we're left with. We're left with a 5 and an x plus 3 minus, which is going to make me be careful. I've got a warning flag there. We've got a 2x and an x plus 3. And we have just a 2x. Distribute, and you get 5x plus 15. Watch that negative. It needs to go through so carefully. Negative 2x times x is negative 2x squared. Negative 2x times 3 is negative 6x is equal to 2x. All right, I'm going to collect my like terms. So negative 2x squared minus x plus 15 equals 2x. We're going to set this equal to 0. So subtract. So then I'm going to end up with negative 2x squared minus 3x plus 15. Now, I personally don't like to factor it with a negative x squared, so I'm going to divide everybody by -1. So I get 2x squared plus 3x minus 15 is equal to 0. Now, I would try to factor this if I could, but it's not going to factor, so we're going to have to use the quadratic formula, where our a value is 2, our b value is 3, and our c value is negative 15. The quadratic formula says negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's negative 3 plus or minus. If you multiply all that on your calculator, you get 129 over 4. If you need more practice on solving rational equations, be sure to watch my practice worksheet on this topic. There you can watch me work more examples. You can even pause the video, try the problem on your own, and then start it back to check your answer. If this video was helpful, please like and subscribe to my channel. This allows me to continue to grow my channel so I can help build your math esteem one problem at a time. See you later.